Welcome to C# for Crestron programming.
In this video, we will introduce the Lambda Operator. In our examples, we will be creating Lambda expressions within common methods to simplify code and allowing for more advanced parsing of data. We will be starting with a C# console app.NET framework project called Basic Lambda. An additional .cs file called dataset has been added to the project with string list of NVX models for us to experiment with. Within our program.cs file, we have our program class, and within the main method have created an object of the dataset class to gain access to the NVX models list. If we wish to output all the models contained within this collection, a basic for each loop can be applied. If we would like to start examining the data by looking for particular items, a helpful approach would be to use pseudocode. Pseudocode is a written description of the processes you'd like to undertake and usually guides you to keywords you can use in programming. Here our pseudocode is: return the index of the value matching dm NVX E30. The list type does contain a built-in method called indexOf that takes a string parameter and gives us what we need. A basic lookup like this works just fine, but as datasets get more complicated or your lookup requirements get more involved, we can use Lambda expressions to enable more powerful methods. The list method of findIndex shows that it requires a predicate as a parameter. A predicate is a delegate. A method can be assigned to a delegate as long as the method's signature matches the delegate's signature. We will be using a Lambda expression to satisfy the conditions of the predicate. Again, start with some pseudocode to help us plan ahead. Our pseudocode, slightly more complex than the last go, is return the item index when the item value at index equals dm NVX E30. You can see that the output result is identical. To further detail the lambda, you can see how it relates to our pseudocode. In our next lookup, we wish to find the index of the last item with 60 in the name. Here we are attempting to use the method lastIndexOf. This method returns -1 as it did not find a match. The lastIndexOf method fails as it is looking for an entire string match. One possible solution While this solution produces the correct result, it is lengthy and difficult to maintain. A more compact lambda expression used with the findLastIndex may be preferable. Lastly, what if our search pattern needs to return more complex data or a set of data? The findAll method will return a list of the same type as the source list while filtering the data based on the entered predicate. Here we can see our new list of filtered data has only the items from the original list containing 60 in the name. You have now seen how Lambda expressions can be used to simplify code like parsing of data sets by leveraging more powerful tools.
Thank you for watching.